Hello, ladies and gentlemen. We are on pre-calc lesson 6. Today's lesson we will talk about fractional exponents, radical equations, EQ means equations, and systems of three linear equations, which is not unfamiliar to us. Let's talk about fractional equations. Fractional equations, okay, the first thing that you need to do is multiply by the LCD. What is the LCD? The LCD is the least common denominator. It's the same thing we do if we had 3 over 2 plus 4 over 3. We would multiply everything by the least common denominator, which is 6. Let's say it equals 1 over 6. We multiply everything by 6. So here the 6 and the 2 cancel, leaving me with 3 times 3. This becomes 4 times 2, and this becomes equals 1 because our 6's cancel. It's the same concept, but this time we will be having equations. Equations meaning that there is a variable. So let's do our first example, example 6.1 on page 49, again, second edition. If we were to solve 4 over 7 plus 3 over x plus 2 equals 5 over 3. We have to figure out what our least common denominator is. In this case, the easiest way to find your least common denominator is to multiply each of your denominator terms. So my least common denominator is 7 times 3 times x plus 2, which I'm going to write as 21 times x plus 2. I'm not going to distribute it, and you will see why. So I'm going to multiply every term by 21 times x plus 2. If you've had me before, you've heard me say the phrase parent evenly, meaning that parents don't choose their favorite child. They love all of their kids the same. You will love each of the terms in your equation the same. This term, this term, this term. We love them the same. We don't pick favorites. So we multiply everything by 21 times x plus 2. Not just your favorite, because you don't have favorites. So this term, I will have 4 over 7 times 21 times x plus 2. Here I will have 3 over x plus 2 times 21 times x plus 2. And I will have 5 over 3 times 21 times x plus 2. Now the reason I didn't multiply out the 21 times x plus 2 is because here the 21 and the 7 cancel, leaving me with 3. In this term, the x plus 2's cancel. And in this term, the 21 and the 3 cancel, leaving me with a 7. So now I have 4 times 3, giving me 12 times x plus 2, plus my 3 times 21, giving me 63 times x plus 2. And over here, I will have my 5 times 7, giving me 35 times x plus 2. Now I want to distribute. So I will have 12x plus 24 plus 63x plus, where am I? 63 times 2 giving me 126 equals 35x plus 70. There's my mistake. I added in an x plus 2 here. My mistake. Just 3 times 21, which is 63. I thought something looked weird. I'm just teaching right now. Just kidding. All right, now I want to combine my x terms on one side, everything else on the other. So I'm going to bring my 12x over here, and I'm going to bring my 70 over here. So on this side I will have 24 plus 63 minus 70, and on this side I will have 35x minus 12x. This will give me 17 equals 23x, so x is simply 17 over 23. At this point, you should always, always, always check your work. If you had made a silly mistake like I made a silly mistake, you would not have gotten the same answer, and it would not satisfy this equation up here. You always need to go back and check your work to make sure that you didn't make silly mistakes like I just showed you. Again, if you have any questions on this at any point in the video, please write it down in your notes and we will talk about it tomorrow. Let's move on and do a different type of equation. Example 6.2 from your book on page 50. We have a system of two equations, two unknowns. In the first equation, we have 3 over 7x plus 2 over 5y equals 11, and 0.03x minus 0.2y equals negative 0.37. This is the same situation where we will multiply each of these equations by the least common denominator. In the first equation, my least common denominator, my denominator I have 7, 5, and 1. So if I multiply all those together, my least common denominator is 35, which is what I will multiply each one by. So here, I will have 3 over 7x times 35 plus 2 over 5y times 35 equals 11 times 35. In this equation, I have decimals, but decimals are really just fractions in disguise, and I can find my least common denominator as 100, because that is my biggest decimal place. So I will have 0.03x times 100 minus 0.2y times 100 equals negative 0.37 times 100. Now comes the fun part, the simplifying. 35 and 7, they cancel, leaving me with 5. 35 and 5 cancel, leaving me with 7. So my top equation, I get 15x plus 14y equals 385. Remember, please use your calculator. There's no need for mental math. And in this equation, second equation, the 100 moves our decimal over 2 places, leaving me with 3x minus 20y equals negative 37. Now, we should be very familiar with the system of two equations, two unknowns, which is what we have here. And we can either choose to use substitution or elimination. Take your pick. It does not matter. I am going to use elimination. If you choose to use substitution, please pause the video, do it yourself, and see if we come up with the same answer. So I am going to multiply this second equation by negative 5. So if I bring down my top equation, I will have 15x plus 14y equals 385. That did not change. But my new bottom equation, I'll have minus 15x plus 100y equals positive 185. I can add these equations together, thus eliminating my x, leaving me with 114y equals 570. Divide both sides by 114, which leaves me with the nice pretty answer of y equals 5. Now, after we solve for y, we take it back to one of these two equations, plug it in, and solve for x. It does not matter which equation that you choose. I'm going to choose the first one. So 15x plus 14 times 5 equals 385. So 15x plus 70 equals 385. So 15x equals 315. X is 315 over 15, leaving me with x is 21. Always, 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 you need to write your answer as an ordered pair. An ordered pair is x, comma, y. That is our final answer. This is if you have a system of equations Your answer is an ordered pair or an ordered triple if we have a system of 3 equations, which we will see later. Again, if you have questions, please write it down. We will go over it tomorrow. Our next section, we have radical equations. In radical equations, the first thing you do is you isolate the radical. The second thing is you raise both sides to the appropriate power. Why both sides? Because we parent evenly. Put a star next to it. If you need to, have your parents watch the video too. Just kidding. And then we repeat if necessary. It is not always necessary. So let's do these steps. Our first example is example 6.3 on page 50. And we were going to solve for x when we have the cube root of x minus 5 minus 2 equals 2. The first thing is I need to isolate the radical, which means the radical doesn't play well with others. So I need to move everything else over to the other side, get it alone, leaving me with the cube root of x minus 5 equals 4. Raise both sides to the appropriate power. In this case, the cube root, we know rewrites this as x minus 5 to the 1/3 power equals 4. If we were to rewrite our radical as an exponential form, and that means I'm going to cube both sides. The reason I cube this is a power raised to a power. We multiply them. 3 times 1/3 is 1. Leaving me with x minus 5 equals 4 cubed, which we should know is 64. And I get x alone, giving me that x is 69. Again, at this point, always, always, always plug your x back in up here. I'll re-emphasize that in our next example, example 6.4 on page 51. This one's a little more difficult because we have multiple radicals. S minus 48 plus the square root of s equals 8. Please don't confuse my s's and my 5's. It's very easy to confuse them. So pay attention to what I am saying, not just what I am writing. The first thing we do is we isolate the radical, but we notice there are 2 radicals. So I'm going to isolate what I call the more complicated radical. The more complicated radical would be this one. So I'm going to have the square root of s minus 48 equals 8 minus the square root of s. Think of it as your sibling that is high maintenance or your friend that is high maintenance. They're high maintenance because it's not just the square root of x, there's something else happening. So we have to isolate the high maintenance friend because they need some special alone time. We all have those friends. Now I raise to the appropriate power, which means I square it. This side will become s minus 48. This side, okay, here's my side note. Very important, 8 minus the square root of s squared is not 8 squared minus the square root of s squared. Never, ever, 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 ever. No, 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 no. Do not make that mistake. If we have 8 minus the square root of s squared, it's 8 minus the square root of s times 8 minus the square root of s, and we have to FOIL. First gives me 64. Outside gives me minus 8 square root of s. Inside gives me minus 8 square root of s. Outside gives me plus s. Combine like terms and simplify. I have s on both sides, which means that they cancel. And I am going to combine these terms, giving me negative 48 equals 64 minus 16 root s. Again, isolate the radical. I'm going to move this over, move that over, leaving me with 16 root s positive because it moved over equals 112. And then I have the square root of s equals 7. Again, square both sides, leaving me with s is 49. Notice how I box my answers every single time. Now, we have to be aware of what we call extraneous solutions. Extraneous solutions is a solution that might not work. Okay? We have to beware that there might be some solutions we cannot plug in, because if we plug it in, it will give us an undefined answer, such as if we took the square root of a negative number. We cannot take a square root of a negative number. We're not using imaginary numbers right now, so we have to be aware of that. So we always take this number and check it. Check your answer. Always. All right. Moving right along to systems of 3 linear equations. We have multiple different ways to solve these. We can use substitution. Yes, I did have to look at how to spell that. And we can also use elimination or both. Sometimes it's a both and situation. So let's do an example. It's the best way to practice math is by doing example 6.5 on page 51. We want to solve the system of equation. We have 2x plus 2y minus z equals 14, 3x plus 3y plus z equals 16, and x minus 2y equals 0. If I look at my equations, this equation I can very simply solve for x. I'm going to do so. X is 2y. I can just add the 2y over. Now I can combine or substitute. I can substitute 2y in for x in both of my top two equations. So I will have 2 times 2y plus 2y minus z equals 14, which that is my first equation. I'm going to simplify. 4y plus 2y minus z equals 14, leaving me with 6y minus z equals 14. That's one of my equations. Don't forget to plug in for x everywhere there's an x. There could be multiple x's in your equation. And now let's do it for our second equation, leaving me with 3 times 2y plus 3y plus z equals 16. Again, I'm going to simplify. 6y plus 3y plus z equals 16, leaving me with 9y plus z equals 16. That is my second equation. Now I'm going to write my two equations together. 6y minus z equals 14 and 9y plus z equals 16. At this point, I can add these together because my z's will eliminate. This gives me 15y equals 30, which I can solve and say y is 2. Now that I know y, I can plug it in to solve for x. X equals 2 times y, so x is 4. And now that I know x and y, I can plug it into any equation and solve for z. I'm going to choose the second equation. So 3 times 4 plus 3 times 2 plus z equals 16. 12 plus 6 plus z equals 16. 12 plus 6 gives me 18, so I will have 16 minus 18, z is negative 2. I am not done. My solution is an ordered triple. 4, 2, negative 2. You always write it as x, y, z. Your solution is and forever will be an ordered triple. As long as we are solving a system of equations, our answer is either an ordered pair or an ordered triple. Again, if you have questions, please write it down and we can talk about it in class. The next part I want you to do in your notes on your own. Example 6.6 from your book, page 52. I will give it to you here so that you can solve it without looking in your book. We have x plus 2y plus z equals 4. 2x minus y minus z equals 0. And 2x minus 2y plus z equals 1. Solve for x, y, and z. I want you to do this in your notes. This is a part of your notes. I will be checking for it. And then tomorrow I will give you the answers in class. If you are so desperate to check your answer, you may check it in the book. That is all we have for this lesson. We'll see you tomorrow.